Hi, so in this video we'll see a deep analysis of the results we obtain. So first of all you can select the file to see the analysis. So we are going to proceed with our file we used earlier, and in this first set of graphs you see how the accuracy varies with the genes found by each method. So in the previous step you only saw the genes found by PCA, random forest and extra tree classifier. But in this graph, you will see a separate column known as the overlap genes. So what this overlap genes means is that, like in the earlier step, if you can remember, you will notice that there were 7 genes that were found by all the 3 methods. So that set of genes we will call as the overlap set of genes. And in this graph, you will see the number of features found. So don't get confused here. Here the PCA means the number of features found only by PCA. That means if you selected 50 from PCA earlier, here it means 50 minus the overlap set. So you will understand why we do this in this manner later. For now, just keep in mind that here what PCA refers is the genes found by PCA but minus the set of overlap genes, and same goes to random forest and extra tree classifier. In this second set of graphs, so we have done an interesting thing. So if we have selected 50 genes earlier, what we have done here is we have gradually decreased the number of genes. So if you start with 50, we go on like 50, 40, 30, 20 until the number of gene count is 1. And then we plot against the accuracy with using the same 3 classifiers we are using for the analysis. So in here you can see how the accuracies vary with the number of genes. So by looking at these graphs, you can see that the highest accuracy can be obtained when using a relatively smaller set of genes rather than considering a larger number of genes. So selecting a smaller set of genes will be more useful in extracting information as well as in getting the highest accuracy in our model. So by doing this analysis, what we are trying to do is to come up with a set of genes that provide the most useful information regarding a particular disease or a target variable. So our ultimate goal is to find those set of genes. And when finding those most useful genes, we have considered an aspect called redundancy. Genes are usually correlated and they might be providing the same information, because if we select 2 genes that are alike, that might not provide some novel or useful information. So to reduce that redundancy, we have plotted the correlation matrix of the genes, and thereby we can see the genes that are least correlated with each other. So the objective of plotting this correlation matrix and getting the least correlated genes is to find the best set of genes that are also impacting a disease, as well as those genes that provide novel information without redundancy. So in here we have a plotted correlation matrix for the genes found by PCA, random forest and extra tree classifier only. So here what you have to make sure is that we have excluded the overlap set. So this bar at the right corner shows the color code with relation to correlation. So the higher the green value is, that means the more possibility that the genes are correlated. And if a square is denoted by a red color, that means like in this instance, that means there's a very less correlation between those two genes. So our objective is to find the set out of PCA, random forest and extra tree classifier that gives the least variation. That means if we look at the color picture, the picture that gives colors of most variety. So here we are going to do a guesswork, and then we select PCA because PCA seems to have more colors than the other two. So we assume that the PCA is the one that gives the least set of correlation genes, and we'll see in the next step whether our choice was correct. So for now we select PCA. So this graph can be used to validate our choice because earlier we chose PCA as the method that gives the least correlated genes. So if we see this graph, it shows if we take a point like 0.94, that means it takes into account the correlation values between 1 to 0.94, and from the y-axis it shows the number of correlated features that belongs to that correlation value as a percentage. So the higher the correlated features value is, that means the higher the correlated genes are within that range. But to reduce redundancy, we need the set that gives the least correlation. So here also you can see, like if we take a point like 0.82, at that point also PCA gives the least correlated genes. So we can say that our choice was correct. So in case if you want to reverse and get another choice, you can go to back and select another method by examining this graph. So the second set of graphs deals with the genes found only by PCA. So in this graph you can see how the correlation coefficients vary with the number of genes selected only by PCA. So the total number of genes found by PCA is 50 minus the overlap set. So in this case it's 7. So 50 minus 7 is around 43. So you can see when the correlation coefficient is 1. So that means between 0 to 1, the whole set of genes is there. So the value there is 43. But if you take the values from here 0 to 0.65, there's only a limited set of genes that are around that correlation coefficient range, and a significant difference occur around 0.83, and that's where the genes become highly correlated, and then it gradually increases. And in the left graph it shows how the classification accuracy varies with the 3 classifiers that we are already using, but with the number of genes found by PCA only. So it shows the same x-axis as the right corner graph. That means at 0.60 or that point it's using only the genes found by this, so must be around 0 to 1 or 2. And at correlation coefficient 1, it means that it has considered all the 43 genes, and you can see how the accuracy varies with the number of genes found only by PCA. So this is a really interesting point to note, because by examining this graph you can see which gives the highest classification accuracy. So in this table we have like 3 methods, 3 classifiers, and we have got the point corresponding to the highest accuracy. So if we get SVM plus Gaussian kernel, that is in blue color, so the highest accuracy is somewhere around here, and the correlation coefficient corresponds to that point is 0.91. And the classification accuracy at that point is around 0.83. So you can get that result from the first row. See, SVM plus Gaussian kernel, the correlation coefficient is 0.91 and the accuracy is 0.83. And at that point you can see the number of features is 20. So how you get the number of features is like the point is here 0.91, and by seeing this graph at the right corner you can see the number of features at that point. So if we get 0.91 here, it's around 20. See, it maps to 20. So we repeat that for the three classifiers we have. So we have maximum accuracies with their corresponding number of features and the correlation coefficients. So now we have three accuracies that corresponds to the three classifiers, and out of these classifiers we are going to use the one that gives the highest accuracy. So in this case it's SVM plus linear kernel, giving an accuracy of 0.844. So as the final result, what we do is, like earlier we had a set of overlap genes obtained, so we'll keep that aside, and from considering the correlation matrices and redundancy, we have got another set of features. So in this case, since the accuracy is 0.844 and it gives the number of features 41, we have this set of genes as the other best set of genes that gives the most useful information as well as the most highest accuracy. So in here we have the overlap features, which we got as 7 features earlier, and from the correlation we have obtained 41 features from the SVM plus linear kernel, and we'll continue with our analysis. So here also a further analysis is represented. So from PCA you selected 41 features, and we have plotted a ROC curve. So for those who are interested, for those who are familiar with machine learning and mathematics and statistics might know what ROC curve means. So that gives a representation of the accuracy of our results. And we have also plotted the correlation matrix considering only those 41 features. And in here we have used the same three classifiers and tested for the training and testing accuracy. And as the next step, what we have done is we have combined our overlap set of genes with the genes found by the PCA. So from PCA we had 41 features, and from overlap features we had 7. So altogether it's 41 plus 7 comes to 48 features. And here also we plot the correlation matrix and the ROC curve, and then we test for their accuracies. So you can see when we combine those features, the overlap set and the features using PCA, we can see that the accuracy can be increased to some extent rather than getting separate genes from the overlap set or the genes considering only the correlation. So that's why we have combined those set of genes. So now we get the highest accuracy from SVM plus Gaussian kernel classifier, and that comes to a training accuracy of 87.446. So since the accuracy is comparatively better than the previous results, we can conclude that our final set of genes will be these 48 features which came from the overlap set plus which came from the PC. So if you want to repeat these results or you want to select another set of genes other than the gene set that comes from PCA, you can also go back and select random forest or extra tree classifier in place of PCA, and then see how the results varies with your choice. So that's about the analysis of your results, and in the next video we'll see how to validate or how to make sure that the results you got was correct from a biological perspective. So let's see in that video. Thank you.